Hi, everyone, and welcome to SharePlex Skills 101. We're excited to have you with us today. We have a special guest joining us, Anu Madukari, Quest's very own product specialist. She'll be sharing her valuable insights and best practices for using SharePlex, the leading data replication solution. There's a lot to cover, so let's dive right in. Anu, I'll hand it over to you.
Hello, everyone. Good morning, good afternoon, good evening. My name is Anu Madhukuri. I'm the Technical Support Manager for SharePlex. Today, I'm going to talk about the best practices for SharePlex. The topics I'm going to cover today are configuration settings and why, and parameter changes for best performance. With the configuration settings, the subtopics which I'll be covering are database supplemental logging, named queues for large deployments, multiple instances of SharePlex. And for the parameter changes for the performance, I'm going to cover about capture, reader, poster parameters, queue parameters, and the export import process parameters. This must be a familiar diagram for some of you. I'll just give a overview, a recap of it, a quick one. Capture is the process which collects the information from the source redo logs and then puts it in the capture queue. Read process reads this capture queue and fills in any information which is missing and then puts it in the export queue. And export process takes this information and gives it to the network layer. Import process picks it up and puts it in the post queue. And the post process it posts the data to the target system, be it a cloud target or an on-prem target or a heterogeneous database as your configuration demands. Okay, now let's dive into the configuration settings and why we do that. The first configuration setting I'm going to talk about is Oracle Database Supplemental Logging. Minimal supplemental logging should be set at the database level, and this is the basic requirement for SharePlex replication. So if this is not enabled, activation process will not be a success. So why do we need this? With the supplemental logging minimum, row ID information is written into the redo log, and this is necessary for SharePlex replication. Now, supplemental logging for PK and UK. As the name suggests, with this supplemental logging enabled, the primary key information is written into the redo log along with the record information. And when capture reads this, it captures the primary key information for the record it is reading. And when reader picks it up, this primary key information is picked up by the reader as well. And this is important for the reader. The reason being, reader has to protect the data integrity. So if this information is not available readily, reader has to query the database and get this information from the database. So with this information available already, reader does not have to go to the database. So reader performance is improved greatly. And the supplemental logging for PK/UK is also needed for open targets, meaning that if you are using PostgreSQL or MySQL or SQL Server target, you'd be using this. You would be needing the supplemental logging for PK/UK enabled on the source system. Now, for peer-to-peer configurations, this is required, and their foreign key supplemental logging is also required. Now, if you're using the transactional concurrency feature for post, this is needed. Now, for CDC replication, that is change data capture replication, supplemental logging for all columns which are being tracked, that has to be enabled. Okay, why do we need name queues? Name queues are needed for large deployments. Uh, Instead of having all the data going into one queue, it helps to have different streams of data going parallelly. So this will isolate the data flow. And this is useful for ease of maintenance. So that if there is any issue in any one of the queues, this is isolated only to that particular queue. And if you want to group related objects, this is needed. For different queues, you can have different parameter settings. Most of the parameters are set at the queue level. So having different queues really helps. And for named queues, you can have named export queues and named post queues. What is a named export queue? A named export queue is an optional user-defined one that is attached to its own export process. Now you can, for multiple targets, you can have separate queues. So instead of having all the data going through one queue, if you have multiple targets, having separate queue makes things much more easier. If you have to abort the configuration, or if you have to re-release any messages, or if you need to maintain any of the queues, so having the separate queue for each target is really helpful. Okay, when SharePlex creates a named export queue process pair, it also creates a dedicated import process on the target system. It creates a post queue and a post process on the target to contain that data stream. So data is isolated all the way from source to the target system. Now, having different settings for different queues really helps here. So this helps for the performance tuning as well. Now let's look at the named post queues. The ease of maintenance, which I mentioned earlier, like for issues with queue corruption, or for maintenance, or stopping the post queue or starting the post queue, all these advantages are there with the named post queues as well. Now, how do we improve the post performance? You can isolate the data from different tables into two or more separate post streams. Now, let's see in which situations it is helpful. You have large tables and you have small tables. Having large tables in a separate queue definitely helps instead of combining them with the smaller tables. And objects that have lob columns. Lob columns, they slow down the replication. So if you have other tables along with the table which has a lob column, it's going to slow down the whole replication process. So instead, you can have these tables in a separate queue by itself. Now, there are objects which involve large transactions, or there could be objects which are involved in a lot of OLTP transactions. So having these separated definitely helps. Now, you know your application and you want any objects, I mean, you know which objects you want to isolate and put it in a separate queue. If you have any such thing, yeah, you can have named post queues. Yeah, one thing which is important and you need to remember is tables with relational dependencies, they need to go into the same post queue. Uh, if uh, if the dependent objects are not replicated through the same post queue, parent and child operations may be applied out of order, and this will cause database errors. As an alternative to processing interdependent objects through the same queue, you can disable their referential constraints on the target system. This may be acceptable because the constraints are satisfied on the source system and then replicated to the target. And the most important thing is you can set different parameter settings for each queue process pair. For example, if you're running a lot of inserts, you might want to set different parameters compared to if you're running small OLTP transactions. So, like I said, most of the queue parameters are set at the most of the parameter settings are at the queue level. So this will really help in the performance tuning. Now we talked about export and the post named queues. Now how are we going to set these queues? There's a command called analyze config, and you run it for n number of days or n number of hours. So what does this command do? It runs the analysis of the tables in the configuration for a period of time specified before you actually activate the configuration. So you run the analysis, you run this command, and all the data is collected in the log file, which is there in the SPSS warder log directory. And you can review that after the period of time. And this captures the typical database activity. And it lists the group of related tables. It also gives you the number of operations per table and the number of operations of the group. So based on this information which you collected, you can actually determine how you want to have your named queues. There's another configuration setting for performance. You can use horizontal partition replication. So what does this do? It divides the rows of the table into separate processing streams. Say you want to replicate only a subset of rows to the target while retaining the rest of the rows in the source. You can use horizontal partitioning. Or you want to replicate different subset of rows to different targets. You can use horizontal partitioning. So basically, you're dividing the replication of the source table into parallel post queues so that faster posting to the target table is happening. Now, how do we do that? Now we have, you can partition the rows based on either column conditions or by using hashing. Now, if the table contains a column that enables you to split the processing evenly among parallel post queue processes, that is perfect. But even otherwise, if you plan to use it's best to use the primary key for this, but you can use any other column if not primary key. Uh, but one thing to remember is you may have to enable the supplemental logging for the column which you choose, or else there could be a reader bottleneck when the reader is processing. So, I mean, reader would have to go to the database to fetch the column information to figure out in which queue the data has to go. The other one is the hash partitioning. So this is a hash-based partitioning scheme. So this directs SharePlex to distribute the rows evenly across multiple queues. The next one I want to talk about is maintaining multiple SharePlex instances. Now, why do we do this? So on the source system, you have multiple source databases which you want to replicate to your target. So instead of having all the source databases in a single SPCOP, you could have multiple SPCOPs. This will help you in better performance and also in the ease of maintenance. The other situation where you might need this is, say you have a single source database and the database is huge and the transaction volume is huge too. And you see that Capture is not able to keep up with the redo log generation. In such cases, you could consider having multiple SPCOPs. Unrelated tables can be put in different instances of SharePlex where replication happens end to end without an issue. And you can have all the SharePlex instances in the same product directory. That is in the same installation. You can have one SPSys prodder and you can have multiple SPSys warder. Now, if any process is slow, so we collect the statistics using the trace command. So in the command prompt, sp control command prompt, you could run the command trace, capture, or read or post whichever process you are trying to trace for n number of minutes, 5 minutes, 10 minutes, whatever time frame you choose. So at the end of the time period, it generates a trace file and a CSV file in the syswarder log directory for the corresponding process traced. And trace post output has a lot more breakdown. It provides the transaction rate, it provides the operation rate, it gives you the transaction mix, rollback mix, and it tells you whether the transactions are small or large, and it gives you a lot of information. And you can use this information for tuning your system. Okay, first we'll look at the capture process. Now you run a trace on capture, and it has generated a trace file and a CSV file. Now when you look at these files, if idle time waiting for data is high or queue push is high, you will increase SPOCT log queue size and SPOCT log read size. If it is a rack system, you multiply this with the number of rack nodes and then increase those parameters. So queue push means basically it's waiting to add a record to the internal queue when the queue is full. And the queue is SPOCT log queue size. And if the time in the checkpoints or queue checkpoint is high, you'll increase the parameters SPOCT checkpoint frequency and also increase SPQQ shem size. SPQQ shem size is a parameter that it's a memory parameter that applies to capture queue and also export queue. Now, write to queue time. If queue write is high, you would increase SPQQ shem size. Queue write is basically the time spent by capture writing to the capture queue. So capture process is spending time writing to the capture queue. And you see that time on lob map is high. So that means capture is spending time on lob related activities. You want to stop capture and you can truncate SharePlex lob map table. And you will also need to set SPOCT enable lob map to 0 and restart capture. But for this to be done, make sure you have supplemental logging for PK and UK enabled on the lob tables. Time on process is high and idle time is 0. That means capture is processing heavily on the given resources. Process time is basically the time that capture is spending processing the redo logs. And the idle, the time that capture is spent waiting, that is sleeping. So all these are tuning parameters. So the suggestions which are given might help. So it is something you need to try and see if they really help you or not. Uh, if you need any assistance, please log in a support case and we'll be able to help you. So now let's look at the reader. In the reader CSV and the trace file, you see that time is high in queue checkpoint. Then you would increase the parameter SPORD R message limit. So what does this do? This parameter controls the frequency of the checkpoints which are performed by the read process. The higher the value of the parameter, the more records that will be held in memory before the checkpoint is triggered. So this causes less IO on the system and faster processing, but at the expense of increased memory usage and longer recovery time. Now, if time is high in queue read and queue write, so read is taking a long time to read the capture queue, or it's taking a longer time to write to the export queue. At that time, you want to increase SPQ queue shim size. If you see that the time is high in key fetch, that means reader is going to the database to fetch the keys. So you want to check your supplemental logging for the tables which are being processed. So you want to enable supplemental logging for the primary key and the unique key on the source database. If you think that time is spent evaluating HP column conditions, you would increase HP ORD HP hash parameter. Now let's look at the best practices for performance of post. So post improvement can be done in multiple ways, increasing the parallel processing, reducing the time of commit, or using connection pooling and thread pooling. SharePlex moved from single-threaded posting to multi-threaded posting. And later, we introduced post enhanced performance, that is PEP, which further improves OLTP processing. Now, looking at these features which we have. Now, PEP, post enhanced performance, this is great for OLTP environment. So that is for short transactions, high concurrency, and high volume customers. For this, the prerequisite is you must enable supplemental logging for PK and UK. If you can enable supplemental logging for foreign key, then it would be even more efficient for post. How does PEP work? PEP checks the dependency in the queue messages and allowing the non-dependent messages to be processed without waiting for the previous commit to finish. This improves the post speed without compromising data integrity. So you could set this parameter to 1 and to invoke this feature. And if you set it to 2, it invokes this feature, plus it enables delete cascade feature. The second one is reducing time on commit. So this was introduced mainly for inserts. So it would speed up post. So if you think that it's being slow on inserts, you would increase SPOPO commit reduced messages. You would increase this parameter value. There's another area where commit speed is increased. That is, you can set the parameter SPOPO commit no wait. You can use that parameter. You can set it to 1. So what it does is it calls the commit wait no wait to help reduce the commit time to finish. It uses the Oracle commit wait no wait call. So you want to use it with caution. And to operate with fewer connections to Oracle, we have a parameter SPOPO connection pool. So this is set as the default parameter. Now, when you run the trace for the post, and when you check the from the CSV or the trace file, you see the time in wait depth is high. So at that point, you want to increase SPOPO commit reduce messages or turn on PEP. If you think that time in queue read is high, you would increase SPQ post shim size. This is a memory parameter. So use caution when you're using this parameter, because if you increase this parameter, and if you have 10 post queues, and this parameter would be applied for each of the post queue. So you just want to check your memory before you set this parameter. If time is being spent in lobs, you want to put the table in a separate queue. And if time is being spent in rollbacks, left to SharePlex, it will resolve the rollbacks by itself. But if you think that is spending a lot of time, you may re-release them manually. You would run the qview -p command multiple times, but you will have to stop the post process before you do that. If time is being spent in key cache, Turn off key cache, set SPOPO max key cache size to 0. Time is spent on Oracle execute or commit. It's time to focus on Oracle tuning. The last process or processes I want to talk about are about export and import being slow. And export and import processes basically they transport data from the source to the target system. And what we observed is performance issues are most likely due to the network issues. Uh, Maybe it's better you could involve the network team too if you run into many such issues. You can run a number of diagnostics like truss, snoop, p files, etc. on both export and the import processes to get more clues to determine why this is being slow. Now, if you have the default parameters set for send buff and receive buff, and if the buffers are incorrectly sized, you can change these buffer sizes. So make sure the send buff on the source and the receive buff on the target, both the parameter values should be the same. There is a chance that it might improve your performance. If network is normal and there are no IO issues, you can work with the below parameters. That is IMP, the import write commit parameters. There is a message count and the timeout parameters. So you can increase these two, and there is a chance that you might get a better performance. You can also set SPXPT keep alive parameter to avoid idle timeout. This is where my presentation ends. Thank you so much for attending the session. If you have any questions, please do log in a case with support. Our next skills 101 SharePlex is about compare and repair. And it would be in a couple of months, and looking forward to seeing you there. Thanks again for attending this call.